Welcome to Lecture 1 on the Introduction to Statistics, and we're going to be talking about the nature of statistics today. You may have an idea about what statistics really is, and you probably come across them in your daily life. So they're numerical facts like the age of people or income for a particular job or sports statistics in general. We're given such a vast amount of information daily, and statistics can help you to understand what this data can actually tell us. Just think about how much data is floating around from watching TikToks to putting information on social media. A book by DeVoe about statistics says that it's fun and sometimes useful to summarize a discipline in just a few words. So let's talk about statistics in a word. They suggest that statistics is all about variation. We don't get the full picture when we collect information or measure it. It's imperfect. And so statistics helps us to understand and model that variation so we can see truth in patterns. So if you think about healthcare in a word, you might be thinking help. Or if you're thinking about accounting in a word, it might be how much. Philosophy is why, and for statistics, it's variation. To define statistics, it is a group of methods used to collect, analyze, present, and interpret data and make decisions. It's also a field of study. There are two branches of statistics, descriptive and inferential, and we're going to talk about both of these in turn. Descriptive statistics consists of our methods of organizing and summarizing information and making those really awesome visuals. So you can think of descriptive statistics as graphs and charts, tables, descriptive measures, so like a count, or a measure of variation, which would be like a standard deviation. There is a movie called Moneyball, and it's based on the Michael Lewis book that follows the general manager Billy Beane's attempt to make a competitive team based on player statistics. And I will post a clip from that movie. It's quite a good one. Anyways, this is a true story. And what happened is the Oakland A's were notoriously, bad at baseball. And so they had very limited money to actually buy good players. So they took an approach where they collected and summarized the relevant data from the game activity to pay for cheap players that had like a specific talent that they might have needed. So they were getting undervalued players, but they were getting on base. In the end, the Oakland A's win 19 consecutive games, tying the longest winning streak. Inferential statistics, on the other hand, is all about taking a bit of information about a population, which is the collection of all individuals or items under consideration, and inferring something about them using a sample, which is the part of the population from which the information was obtained. So it consists of methods that use sample results to help make decisions and predictions about a population. So when we talk about a population and a sample, the population is the collection of all individuals or items under consideration, and the sample is the part of the population from which information is obtained. Statisticians analyze information obtained from a sample of a population to make inferences and draw conclusions. And an example of that would be a survey. This figure is a good illustration of how the population and the sample are related. You always have to use your descriptive techniques to organize and summarize the information obtained from a sample before you can carry out any sort of inferential analysis. This is why in this course we'll be focusing a lot on the descriptive side for a big portion of it before moving into the inferential. This definition comes straight from the Weiss textbook, and I thought it was a nice way to sum up inferential statistics, so I thought I'd throw it in here as well. Inferential statistic consists of methods for drawing and measuring the reliability of conclusions about a population based on information obtained from a sample of the population. And it's going to be very important as we go through that you recognize that samples and populations are different. And even when we are calculating certain items like the mean, you might use the same process, but the symbols are different because samples and populations are different. In this part, we're going to start to classify statistical studies as either descriptive or inferential. And in doing so, you need to consider what is the purpose of this statistical study. So, for example, if the purpose of a study is just to examine or explore information, then it's generally descriptive. But if the information you are getting is from a sample of a population, and the purpose of the study is to use that information to draw a conclusion or make an inference, then it will be an inferential study. So a descriptive study may be performed either on a sample or on a population. Only when an inference is made about the population based on any of your information obtained does this become inferential. So if you look at the example I have, we've got the voting results from the 2020 presidential election, and we're looking at Arizona and Florida. And you can see that Joe Biden won Arizona, Donald Trump won Florida. This is a summary, and it doesn't actually infer anything. So this would be classified as a descriptive study. Descriptive statistics was developed before inferential statistics. And a great example of this, and shown here, are census records, where we kept track of how many people were in a household and their ages and possibly their jobs and gender. Besides classifying statistical studies as either descriptive or inferential, we often need to classify them as either observational studies or designed experiments. So we'll talk about those in turn. So let's define them. Observational studies are when researchers observe characteristics and take measurements. Note that in an observational study, someone's just observing data that already exist. So that means the data were there and would be there whether someone was interested in them, or not. A designed experiment is when researchers impose treatments and controls. In a designed experiment, the data do not exist until somebody does something, like the experiment, to actually produce the data. So let's do a little practice. And I'll pull practice from the textbook, but I'll also design some of them myself so that you've got multiple places that you can practice. So, vasectomies and prostate cancers. Researchers concluded that about 60% of men who have had a vasectomy end up with prostate cancer, revealing an association. And if we were going to try to classify this, this would be descriptive, and it is a simple observation. The researchers observed two groups of men, one with vasectomies and the other without, and they established an association. Flat Earth. A recent poll of more than 500 Albertans taken in July 2020 has shown that many Albertans believe the Earth is flat. Of those sampled, about 69% were in agreement the Earth is flat. Identify the population and the sample of the study. Is this percentage descriptive or inferential? So the population would be all Albertans, and the sample are the 500 Albertans from the poll. This percentage is descriptive. We cannot infer anything from it. Thanks for watching. See you next time.